So question 10, it wants to solve this equation. 2 to the x squared minus 16 is equal to 4 to the 3x. So I'm going to quit this over here again. That off there. Clear that off. So again, one of the strategies is at this time is if I can make the bases the same, then I can set the exponents equal to each other. So notice how again I have this 4 here. And we've learned that 2 squared is actually equal to 4. So keep that in mind as we move forward. We have that going on. So what I can do is leave the left side like it is. So I have 2 to the x squared minus 16. And what I can do is I can change this 4 to 2 squared. But it's still raised to the 3x power. And what we learned is a power to a power, we can actually multiply those exponents together to simplify that. So this becomes 2 to the x squared minus 16 is equal to 2 to the 6x power. Now, since the bases are the same, I can set the exponents equal to each other. That should be x squared minus 16. So what I can do now is write this as x squared minus 16 is equal to 6x. And what I can do is bring the 6x over. Since it's the linear term, it wants to be in the middle. So this becomes x squared minus 6x minus 16 is equal to 0. Now the question is, it's quadratic, is it factorable? Are there some factors of a negative 16 that would give me a negative 6? Well, the factors of 16 I'm thinking are 1 and 16, 2 and an 8, and a 4 times a 4. This 2 times 8 looks very promising because if I make this 8 a negative, 2 times negative 8 is negative 16, and 2 plus negative 8 is a negative 6. So this looks like it makes it factorable. So what happens is I can change this to then x plus 2 times x minus 8 is equal to 0. And then we can set each factor equal to 0. So for x, we get x equals negative 2, and we get x equals 8. So that would be our two zeros, negative 2 and 8. So again, if I bring this over to the other side up here, I can write this as y equals and clear this off. I could type in 2 to the x squared minus 16, and this 4 to the 3x becomes a negative 1 or a minus over here. 4 to the 3x. If I graph that, you can see that's what our graph looks like. But notice how it has some zeros here. There looks like there's one at over here somewhere. We're thinking negative 2. So if we look at the table, notice that negative 2, 0, that looks correct. And notice that these other values, it looks like we have this asymptote happening here. So we also have some domain restrictions going on. So it looks like if once you get to around this area, we get a domain restriction that you can't even go past that. Notice that the other 0 we pick up on is, notice that 8 is a 0 in the table as well. So we can kind of verify looking at that table that those were the two zeros. Or again, you could use your calculate button to see that. But since these were integers, the table should be able to pick up on those.